And we're going to go ahead and move on to, let's go with data. Measurement is 900 mastery points, and I figure I'm going to do measurement and geometry and the course challenge in the next stream. So for now, we're going to go ahead and do this data topic. So let's make some picture graphs. What's that even mean, picture graphs? A group of students went whale watching on a field trip. So we've got Ronaldo, who saw 2 whales, and we saw Marcella, who got 4 whales, and we see Ali, who saw 3 whales, and we see Fernando, who saw 5 whales. Create a picture graph to show how many whales each student saw. So that makes sense, right? So we're gonna have, let's see, for Ronaldo, that is 2 whales for him, yeah? It's a bar graph with pictures. It's nice and easy, I hope. Marcella saw 4, so I'm going to go 1, 2, 3, 4. I just clicked at the spot where I thought it would be 4. If I clicked too high and got 5, that would be fine. I could just click on the 4, bring it back down to where it belongs. How many did Ali see? Ali saw 3, which is here. And Fernando saw 5, which is up here. So this is a visual representation of what the 4 students saw. Now, this is important. We see that each picture of a penguin actually counts as 1 penguin. It doesn't have to, right? We could have 1 picture of a penguin represent a colony of 100 penguins if we wanted, but we're not doing that. We're making sure that each picture of a penguin is worth 1 penguin. So it looks like Sven saw 2. It looks like Olaf saw 6. I wonder where they got these names from. Anna saw 4. And Elsa saw 1, 2, 3, 4, 5, 6, 7, 8. Let it go. Let it go. Can't go any further than that without getting demonetized. Not that I'm monetizing these videos anyway. Boom. Moving on. The monkey is at the zoo. Not good. Khan Academy. I know this is a math lesson, but for God's sake, you are an educational facility. Do not get these kinds of things wrong. The monkeys, without an apostrophe, at the zoo were given bananas. So I see that Mel got 2 bananas. I see that Maxie got 1, 2, 3, 4, 5, 6 bananas. And I see that Marcy got 5. 2, 6, 5. Moving on. Hey, Miss Owen counted how many glasses of milk some of her students drank at lunch. I very much doubt there are people drinking 5 to 7 glasses of milk in lunch, but you know, you never know. Some people really, really, really like milk. If one of these pictures equals 1 glass of milk, then Duo, the bird from Duolingo, got 1, 2, 3, 4, 5 glasses of milk at lunch. Tom looks like he only drank 1, like a normal human being. Well done, Tom. Leah looks like she drank 4. And Ashish looks like 1, 2, 3, 4, 5, 6 glasses of milk in 1 lunch. I'm sure that's a thing that people really do in real life. Moving on. Some students collected some ladybugs. We have 4 for Jen, 6 for Lee, 5 for Sarah. If 1 picture of a ladybug equals 1 ladybug, we're going to say that Jen has 1, 2, 3, 4. Lee has 6, so that's 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, if I accidentally made too many, I can always take 1 out. That's no problem. And then Sarah has 1, 2, 3, 4, 5 right there. This is just counting again, right? I hope you can see this is not new math. This is just the same counting we've been doing from the beginning, and this is actually easier. This is easier than the bar graphs that we did last stream, in first grade, because instead of a bar that we have to count up, we can actually see the number of ladybugs and count them up, as opposed to having to sort of interpret a bar graph. San Diego has 1, 2, 3, 4, 5, 6 monkey books. 4 for Madrid. 2 for Tokyo. And 1, 2, 3, 4, 5 for Chester. Moving on. Johnny Appleseed. Ah, yes. One of those American myths about a colonizer who liked to kill lots and lots and lots of native people and plant non-native plants in order to ruin the ecosystem. Johnny Appleseed, thank you very much for, ruining the ecosystem. But he planted 2 apple seeds in Charleston, so that will be 2. He planted 6 apple seeds in Louisville, 1, 2, 3, 4, 5, 6. He planted 5 in Richmond, and he planted 6 in one of the many, many, many spring fields we have in this United States. You'd be amazed how many towns there are named Springfield in the United States. Look it up. That's that. Making picture graphs is done. Let's move on to the next thing. Solve problems with picture graphs. Okay, so now we're going to be given a picture graph and asked to solve a problem using it. Let's take a look. Sharks. Why does it have to be sharks? I'm scared of sharks. Okay. Jojo. Jojo! Get you a friend like, what's his name? Sidecar from Jojo. Sidecar? What the hell was his name? Anyway, doesn't matter. Sharks. How many total sharks did Jojo see? Well, if each picture is worth 1 shark, we don't even have to worry about the days. We just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are a total of 11 sharks. And because each picture of a shark is worth 1 shark, that means that Jojo saw 11 sharks altogether. No problem. There are 14 toy whales in a swimming pool. How many toy whales does Lena have? Well, there are 14 total, and I see 1, 2, 3 of them in Lena's column, so Lena has 3 toy whales. Romaine has a garden with 4 types of flowers. Below is a picture graph of the flowers in the garden. So I see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sunflowers. This looks like 6 daisies. This looks like 10 roses and 3 tulips. So if we're going to take roses and daisies and put them together, oh man, addition with words and graphs. I don't know how to do this. I'm so scared. I'm so tired. I don't know what to do. It's fine. Roses, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, plus daisies, 11, 12, 13, 14, 15, 16. There's a total of 16 roses and daisies all together. It's just addition. Don't be afraid of the words. Don't be afraid of the pictures. It's the same addition we've been doing this whole time. At the apple orchard, several students ate apples. They made a picture graph to show how many apples they ate. Wow, some of these people are really good at eating apples. I would not be able to eat 1, 2, 3, 4, 5 apples all at once, I don't think. Anyway, how many more apples did Sophia eat than Laura? When we talk about how many more one person ate than another, that is a subtraction problem. So mathematically what we're doing is 5 minus 3 equals 2. But visually, without having to do the math, because so much of math is about avoiding doing math. Like, it's kind of ridiculous how much of math exists just to prevent you from having to do more math. So if we look at Laura here, and we put a line, that's not right, and we put a line horizontally at where Laura is, right? She has 3 apples. How many more does Sophia have? Well, without having to do the math, we can actually visually see that there are 2 more that Sophia has than Laura. That's the whole point of these graphs, is so that you don't have to do the math. You can literally just see. You can just look at it and see that there are 2 more apples in Sophia's belly than in Laura's. And that is solve problems with picture graphs. Moving on, we are doing so well, my friends. We have a quick quiz about these 2 picture graphs, so we're gonna go through that really fast. All right, we're gonna nail this quiz super quick. Lou has different flowers. I see 3 roses. I see 1, 2, 3, 4, 5, 6, 7 daffodils. I see 5 tulips, and I see 8 daisies. Ray is making a nutty trail mix. We've got 4 different types of nuts: peanuts, cashews, peanuts. I'm watching you. Don't make any inappropriate comments. 1 peanut, 2 cashews, 3 almonds, and 1, 2, 3, 4, 5 walnuts. The total number of nuts is 5, 6, 7, 8, 9, 10, 11. We have 6 roses, 3 daffodils, 3 tulips. That should be easy enough. 1, 2, 3, 4, 5, 6 roses, and then 3 each of daffodils and tulips. 6, 3, 3. There are 15 mice on Farmer Green's farm. How many mice were found total? Again, this is just a counting problem, right? You don't actually have to know how graphs work. The fact is, this particular graph is going left and right instead of up and down. What the heck? What is even going on here? Why is it that we've got our location is the vertical axis and we're counting up to the right instead of up? But it doesn't matter. Don't let it scare you, friends. It doesn't change the fact that there is a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 mice all told. The actual order and sort of direction that we stack them up doesn't matter. Don't let it fool you. Okay, so what did I just say? 2, 6, 7, 8, 9, 10, 11, 12, 15. Okay, so I see 15 mice. Moving on. I didn't get 15 mice. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, there were only 1, 2, 3, 4, 5, 6 of them found in the barn. This was not. This is an excellent chance. As I made a mistake, as I am wont to do, and as everybody is wont to do, what I thought was that the problem was asking us to total all of the mice together to make 15. But that is not what the problem is saying. The problem is saying how many are specifically in the barn. And the barn only has 1, 2, 3, 4, 5, 6 mice. Anybody can misinterpret a word problem and solve for a thing correctly that wasn't the thing they were supposed to solve for. It's totally natural, it's totally normal, and it's why I try so hard to push the idea that math and language arts are actually very much linked, they very much overlap, they are basically the same thing. So, got that right? A pet store fed their bunnies carrots for a snack. I see Hopper, Thumper, Bugs, and Oreo. I used to have a cat named Oreo. I will let you guess what 2 colors that cat was. So Hopper has 1, 2, 3, 4, 5, 6 carrots. Thumper has 1, 2, 3, 4 carrots. Bugs has 2. Yeah, what's up, Doc? And Oreo has 3. And that's that. I got 80%, but that's okay. We will make it up later on in the unit quiz, or the unit test.